Okay, good morning, everybody tuning in remotely or asynchronously. If you're watching this video, congratulations to you. You're just a great student. And you're probably already doing fantastic in my class. But there was one point on the test that looked like something that was a little confusing to us, something that we needed to work on. And I wanted to provide a little bit more understanding and an opportunity to work on some problems that will give you test correction scores back. Test corrections added to your score. Anyways, we're going to do a couple we do problems that look very similar to the test correction problems or the test problems themselves. And so what you'll see here is two very, very similar questions. And in fact, I have this question wrong. I'm going to have to re-upload the document. But you'll see a slightly different version on the test. So we're going to focus just on these we do problems and how I attack equations with sine and cosine. Now let's remember, our answers are going to look like an angle. Our angles are going to go from 0 to 360 degrees. Remember that 2 pi is just in radians. It's a different way of saying 360. So we're looking for angles. That's really important. We've got to make sure that we have our chart in front of us with sine, cosine, tangent, and the 30, 45, 60. Right? And we're going to try to get back to either 30, 45, or 60 degrees. Well, how do we do so? Well, in this scenario, we've got a sine. Now that's important. So I might be tempted to look at my chart and find where is sine equal to anything that looks like this. But you probably have a great understanding of trying to isolate in order to solve for something. All right. And so inverse operations here are key, dividing by 8. Now we do have a fraction, 4/8 here. And you might be saying that's not on our chart. Let's reduce that. And if I reduce this by 4 on the top and bottom, let's see, what does that give me? Well, that cancels out the 4. And then I'm left with a 2 on the bottom. Now, if I look over at my chart for sine, cosine, and tangent, and I look over for sine at radical 3/2, I will see that it lines up with 60 degrees, which is the same thing as pi/3. I'm just using my chart. Okay. And so what that tells me is really what angle is possible here, or at least the reference angle that I'm going to use to get radical 3/2. This could be an answer. 60 degrees could be an answer. It's at least the reference angle. How do I know if it's an answer or not? Well, it really depends on what is the sign of our answer. Well, this is positive. So what we really need to do, and this is what I need to see from everybody on every single one of these, is once you get your reference angle, go check to see where is sine positive. Well, sine is positive here, and everything is positive here. How does that help me? Well, it helps me because this is quadrant 1 and this is quadrant 2, and we've got some little formulas that we can use for each one of those. So for quadrant 1, we just leave everything the same. Remember, that's between 0 and 90 degrees. So 60 degrees is in quadrant 1, so we can use it as an answer in this case. Isn't always the case. In quadrant 2, we can see that our angles go from 90 to 180. 60 doesn't fit in there. So what is our formula to take our reference angle of 60 and make it in between 180 and 90? Well, we just take it and we subtract it from 180. And we get something like 120 degrees. Now, these two are the only two angles, let's think back, that will give us this radical 3/2 and be positive for sine. You could check it. Take sine of 60. Take sine of 120. You should get radical 3/2. And the last step here is to go back and check our answer and make sure that it's between 0 and 2 pi in terms of pi. Well, I know that 60 is pi/3. I'm thinking of pi as 180. 18 divided by 3 is 6. And 2 of those, right? 2 of those will get me to 120. So 120 is just going to be 2 pi/3. Here are our answers. So what we need to focus on is isolating sine. Let me go put some check marks next to my steps. Isolating sine, finding our reference angle, finding where that reference angle is, in this case, positive, and then, of course, converting those into pi or radians. Now let's take a look at a slightly more complicated example. This next one we can see has several signs, and it even has an exponent of 2. which is really important. A lot of us understand that this is a quadratic. And so we replace all the signs with u. This is called u substitution in order to solve it first. Because it's going to be hard to isolate u with sign with all of that junk there. So since this is a quadratic, we want to set this equal to 0. That's how we always solve these. So I'm going to add 1 to both sides. And now we're ready to solve, but we're not going to solve with inverse operations. We're going to solve by factoring. And so are there GCFs here? No. Is the a term greater than 1? Yes. So I've got to do factoring by grouping a times c. 2 times 1, which is 2. And now I've got to look for factors of 2. There's only 2 of them, 2 and 1. Do those also add up to get me 3? Absolutely. And so remember that when we're factoring, we're looking for numbers that multiply to give us that c term, or in this term, a times c, but also add to give us 3. And so now we can take these two things and we can plug them in the place of 3. So we're going to have 2u squared. Notice how that comes down. The 3u turns into a plus 2u plus 1u plus 1 equals 0. Reflect what happened here. The 3u split into these two. Why? Because I did my factoring over off to the side, and that's how factoring by grouping works. Now we can take the GCF. This is just factoring to find a solution. There's 2u that they have in common, so we'll bring that out front, divide them both. We have a u and a plus 1 left. This 2 goes out front. Oh, I lied about that. I lied about that. That's not true at all. We can only divide that by a 1. So that 1's going to go out front, and we still have the same thing on the inside of parentheses. Now, when we put these together, remember that the 2u plus 1 go together, and then just the regular u plus 1 go together. Now, this is all just to get some solutions here. So now that I've got down to here, we can solve this really quickly. Subtract 1, divide by 2. I get a negative 1/2 and a negative 1. You might be tempted to say that you're done. You have our solution. This is how we factor. This is how we solve. But remember that our very first step here was really just to solve to figure out what sine is. We need an angle. These are not angles. And so we need to plug sine back in, which in this case has a theta. And now we've got to solve these mini equations. We'll work one at a time. This first one tells me that sine is negative 1/2. I'm going to refer, how did I do my steps over here with sine, right? Over in this problem. Well, I'm looking for angles where sine is this time negative, positive, positive, negative, negative. And so what's my reference angle? My reference angle this time, using my chart, I would see that I have 30 degrees and 1/2. So therefore my angle, my reference angle is going to be 30 degrees. This time it's not necessarily an answer because I need to do two things. I need to add 180 to that, and I need to subtract 360 by that reference angle. And so we're going to have two answers. Let's put our answers way up here because I'm running out of space. I'm going to have 210. That's 30 plus 180. And I'm going to have 330 because that's that same 30 subtracted from 360. So I've got two angles so far. They are from 0 to 360 on my unit circle that would make this sine of negative 1/2. But we've also got to do that for sine of negative 1. And if we look at our chart, remember sine is our y value. Where is that going to be? Right down here, which is at 270 degrees. So these are our answers. And now we're just going to really quickly turn those in terms of pi. 30 degrees is pi over 6. So that's going to, 210 is 7 pi over 6. 330 is 11 pi over 6. And 270, that's one that I want you to have memorized, is 3 pi over 2. These are our answers. Let's take a look. This one was quite a bit more lengthy and difficult. We started this problem with a whole bunch of signs and we replaced them just with u's. So anywhere that I see a sign, we replaced it just with a u so that we could factor. And then once we got those factors down here, we could end up solving for u. But notice how we didn't stop there. Once we solve for u, we plugged sine back in order to check to see where our angles would be. So we used our reference chart to find our reference angle. 30 gives us 1/2. And then we used our ASTC to find out where things would be positive and negative, because of course our answers need to be angles. That's what we're looking for, angles from 0 to 2 pi or 0 to 360. So the next thing that you've got to do is now take these, make sure that they're written down, and repeat this process. The questions will be slightly different. Use what we've just talked about, reference it, do it, submit it, and I'll give you credit. Thanks for being here. I'll check my video count. Let's see if we can break double digits today. Have a great Friday and a good weekend.